Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Pair I, Newman projection versus wedge dash of the same compound. The Newman projection shows front carbon F, top, Br, upper left, H, upper right, back carbon H, lower left, CH3, lower right, H, bottom. The wedge dash shows a single stereocenter with H, wedge, CH to Br. Wait, re-examining, the right structure of pair I has H3C, H, CH to Br, and F on one carbon, making it a single chiral center. The Newman also encodes one chiral center. The front carbon bears F, Br, H, but actually only one carbon is chiral in a Newman if the back carbon has two H's. Assign RS to both. In the Newman, front carbon has F, Br, H, priority F, Br, H, with the carbon chain going back. In the wedge dash, the same four groups are present. Careful comparison of the spatial arrangement reveals they are non-superimposable mirror images enantiomers. Step 2. Pair 2 stereocenters each. Each molecule has two stereocenters bearing Cl, H, CH3, CH to CH3, i.e. 2,3 dichloropentane framework or similar. Assign RS at each stereocenter for both structures. For the left structure, assign configurations at C1 and C2. For the right structure, assign configurations at C1 and C2. The analysis shows that the configurations at the two centers are RS in 1 and SR. Or more carefully, one center is inverted and the other is not between the two structures. When one but not both stereocenters are inverted, the compounds are diastereomers, not mirror images of each other overall. Therefore, pair 2 is equal to diastereomers. Step 3. Pair 3 to cross Sohor's structures of 2,3 dibromobutane. Left structure, top carbon CH3, up, H, left, Br, right, bottom carbon CH3, left, H, right, Br, down. This corresponds to one configuration at each carbon. Right structure, top carbon CH3, up, Br, left, H, right, bottom carbon H, left, CH3, right, Br, down. By rotating flipping one structure, we can check if they superimpose. Rotating the right structure 180 degrees about the C bond axis maps it onto the left structure exactly. Hence they are identical, same compound. Summary: I is equal to enantiomers, 2 is equal to diastereomers, 3 is equal to identical matches option C. Why other options fail? A says 3 is equal to enantiomers, but 3 structures are identical after rotation. B says I is equal to identical, but they are non-superimposable mirror images. D says 2 is equal to identical, but the two stereocenters are not both inverted, giving diastereomers. Therefore, the correct answer is C. Therefore, the correct answer is option C.